Today, I'm going to talk about the connection between data compression and wisdom, however tenuous that may originally seem. And this research actually started based on an intuition that a lot of computer scientists hold about the nature of data compression, namely that it is the analog of wisdom in a technical environment. The theme of the project is we want to interpret wisdom in an unbiased reality. And you can abstract this as we just have a whole ton of raw data, bioinformatics, email, geographical information, some kind of sensor data that's sitting out in the world someplace. We just collect massive amounts of data and we want to sort of figure out the wisdom of this situation. And what we want to do particularly is to take data in this raw, unadulterated sort of form. We want to compress it, which we're going to argue is wisdom. And the other thing we want to do is be able to access that wisdom quickly and give those answers back to people who care about it. What I'm going to do is use the classic scholar in this notion of wisdom, which is Sherlock Holmes. Sherlock Holmes, these stories involve two main characters. Dr. Watson, who serves mainly to provide you an unbiased, real-life view of the data that's available. What the scene looks like, where this footstep is, all that sort of stuff. And Sherlock Holmes takes this data, segregates it, prioritizes it in some way, and then comes up with the underlying truth. Who killed whom, who ran off with whom, who adulterated with whom, whatever it is, depending on the story that you're reading. And the segregation and the prioritization process is not exactly a logical process. You can think of it as you have a huge number of choices about how you're going to try to determine an underlying truth, and you're just sort of, based on a gut feeling, going to blindly walk down one of those paths and see if it works out. Of course, the beauty of Sherlock Holmes is it always does. Okay, so if we sort of, I'm going to describe some technical terms based on that. Each description that we describe can be written down using a certain amount of computer memory. Okay? This amount of memory can be expressed mathematically, and we call that a measure, in much the same way that you guys call things measures. And there are formulas for this and that sort of thing. It depends on what measure you choose. So certain measures are better at representing certain types of information, or better at anticipating certain kinds of things than other measures. And there's some finesse and an art to choosing the measure. Okay? The last thing I'm going to talk about is, so I spent all that time talking about compression. Now I'm going to talk about wisdom in reasonable time. We're impatient these days, and we just really can't wait for 30 years for somebody to tell us the answer to some question we want, or whether we should invest in this stock or whatever. So what we want is to have access to the wisdom that whatever system it is that we can have, we want it now. We want that access now. And we want to not only be able to access it, but we want to be able to use it in useful ways. And the goal here is we're going to create something called an index to help us get answers in reasonable time. Okay, so here's some conclusions from searching. Compression represents the passive manifestation of wisdom captured by a data structure, and it's important for us not to manipulate that compression, but merely to analyze it. The next thing is accessing wisdom is critical, perhaps even more critical than the actual wisdom that's held in the data structure itself. Access speed should ideally be related to the compression ratio. So if you know more about the data, if you can compress it better, then you should really get answers faster. Huffman coding is an example of that exists. And opportunistic compression is something that I came up with in this data structure, which is you compress only when you need to. And the answers that you care about are the ones that are compressed. And we came up with a couple of questions. I have partial answers for some of these, and I've talked to some others of you about some of these. But the first question is, how is wisdom distinct from information content? In other words, how is it that the minimum compression that you can achieve for a file is somehow different than the inference that you would make about that information? And part of that has to do with the fact that the process is part of developing wisdom. The compression measure you use, how you achieve that compression, is a part and a parcel of that wisdom component. And the second question is there some subset of wisdom that we can all sort of agree is universally acceptable? Not that the wisdom itself spans all possible contexts, but that if you have a particular piece of wisdom or something that's identified as such in a particular context, would everybody or almost everybody agree that, yeah, that's pretty much true?